All right, let's go ahead and do 1b this time. Let's do the same thing. Let's work on a graph and we'll simultaneously create an equation for it. So we have a hole at x equals -2. So let's go 1, 2, give ourselves a little reminder that there's a hole there. And let's start writing our equation. Y equals, if there's a hole, again, we need to have that factor in the numerator and in the denominator as well. So if that hole is at -2, we need an x plus 2 in the top and bottom. We want a vertical asymptote at x equals +9, which means we need a factor of x minus 9 in the bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's sketch that in. So we currently have something that looks like this. And then the last thing we're told is there's an x-intercept at x equals 0, which means we must have a power of x in the numerator, giving us that x-intercept at x equals 0. And we can draw that on our graph by putting our point there. All right. The last thing we're told is a horizontal asymptote at the x-axis, which is actually problematic for us because if we want the horizontal asymptote to be at the x-axis, like we said in the previous problem, we need the degree on the denominator to be larger than the degree on the numerator. So what are we going to do? Well, we could add another vertical asymptote in there, and then it would certainly be a larger degree on the denominator, and that's fine. You can add additional graphical features. But another way we could handle it without adding any additional graphical features is we could just change the multiplicity on that asymptote to a 3, because if it's a 3, it's still going to have the same behavior, but now the degree on the denominator is clearly going to be bigger than the degree in the numerator. I could even have made it 2 if I wanted to, because I'm not told that my tails have to be on the same side. But let's stick with this. Let's make it 3, and let's graph it in. So, how do we know where to start? Because our horizontal asymptote is at 0, y value of 0, so we don't have that idea of x-intercepts to help us out. But we do have the idea of positive and negative factors. So first off, this x plus 2 over x plus 2, not affecting my graph, right? Except for that hole, it's not doing anything. So when I'm thinking about these functions, let's focus on this, because x plus 2 over x plus 2, again, not going to affect positive or negative of my graph. So I'm dealing with x over x minus 9 cubed. So what I like to do is I like to think about really positive x values, like really big positive x values, and then I just figure out, well, is that going to make that fraction, x over x minus 9 cubed, positive or negative? So what happens to the numerator when x is a really, really big number? Well, in the numerator, we just have a power of x. So if you plug in a really big x value, you're going to get a really big positive x value. What happens in the denominator? If you plug in a really big positive x value to the denominator, like say 100, well, 100 minus 9 is a positive number, and if you cube a positive number, it's positive. So we're getting a positive over a positive number, which is telling me that my branch should be positive when I'm to the right of that asymptote. A little reasoning game there. All right, well then what's going to happen on the left of the asymptote? Well, since my asymptote is of an odd degree, it is going to be down. Since to the right of it I'm up, to the left of it I'm down, because the multiplicity of the x minus 9 factor creating the asymptote is odd. I have to be going to the opposite infinity. If I had made it x minus 9 squared, I would have also started up. But I made it cubed, so I'm starting down, and then I'm going to come over. I'm going to hit this x-intercept. I'm going to cross because my degree is odd. And then I'm going to kind of pop up and then level out because I have a horizontal asymptote at 0. So it's going to look something like that. And I need to show that I have a hole here. So we'll erase that bit and I will put my hole in. So there we go. Oh, maybe we'll connect that a little bit better. All right. So this is what we got. Something that looks like that. And again, is this the only possible graph you could have come up with? Only possible equation you could have come up with? Absolutely not. But it is one possibility. And again, I think probably the simplest possibility, other than making it squared, x minus 9 squared, would have also been simple.